Hello, everyone. You're going to hear a few things again, which is great from a different angle. Before we start, I would like everyone to close your eyes. Everyone, close your eyes. If you don't do it, I can see it. Close your eyes. Now create a room. It's not any room you know. Just create a room you don't know. Create it from scratch. Put something in the center. Maybe, I don't know, a desk, something in the center of that room. And you stand right in front of that. Now put something on top of that desk or whatever you put there. It can be an object, it can be a plant, it can be whatever you want. Now, imagine yourself grabbing that thing, lifting it up, looking at it. All right, you can open your eyes now. You just created a new world. I'm done, thank you, bye. Okay, I'm Jon, as it's been said many times. Jon is short for Jonatas, but for some reason, many British people can't say Jonatas properly. So yeah, there you go, it's Jon. Here's my LinkedIn if you guys want to connect. I was a contractor for quite a bit, and I worked for many weird, different interface design companies. The last before Meta, actually in between Meta engagements that I had, I worked for automotive for a while, which was a passion of mine until I had to go back to designing in Photoshop, which was like, oh no. So that goes again my point about tools. Be open, guys, be open. And yeah, today I work for Meta, and we'll talk a bit more about that. And I work for a team called Workrooms, which today has a different name internally. We basically, historically, since 2020, when I joined, we used to build tools for collaboration, work in VR. Today, we also build technology for collaboration in general and for co-presence. And for maybe half of my time at Meta, I also worked for Meta Spark. And Spark is, or was, now Spark evolved to something else, but it was Meta's AR ecosystem. Basically, the stuff you saw right now about like Orion, if you saw the new announcements from Meta, AR glasses and this type of thing, Spark was the previous ecosystem that evolved to something that is now Meta AR SDK. And I was part of this team for quite a bit. And basically, they created tools for people to create AR. So it's kind of a layer behind doing AR itself. And today I'm back at Workrooms, building those things I mentioned to you just now. And I would like to start with this quote, which is, "Our dreams take us into other worlds, alternative realities that help us make sense of the day-to-day realities." This is a quote from Tom Hodgkinson, and I will not pretend I know him, but the quote is quite good. And the thing is that I have always been fascinated about this idea of creating new things, new worlds. As a kid, maybe I was too imaginative, and this always fascinated me. And I actually did this through a different way, via dreaming. I'm not a very prolific lucid dreamer, but I do quite a bit of dream work. I even have a dream journal with like hundreds of dreams, and I have a few experiences I can talk to you about with time, another time. And at the same time, as a kid, this is me just a few years ago, I have always been fascinated about how technology helped me do that, maybe with video games and with being a computer, and I was like immersed in that world, and there was nothing else. And that played pretty much like a huge part of me becoming a designer one day. And that's what VR helps you do. Although it's a very new technology, not really adopted by everyone, and like there's many hoops we need to jump until this become a thing that everybody uses, like my grandma, like I said before. It still already allows you to create new worlds, new spaces, and lets you do things that you cannot really do in real life. But what does it really mean being a product designer in VR? And I will give you a view of how that is at Reality Labs specifically. But that is very similar in many VR teams around different companies. And basically, a core Meta team has those three roles: product, content design, and UX research. That's a traditional Meta team. And it's kind of the same in many companies, as you know. When you go to the VR teams, you also add prototypers and artists. And as your core day-to-day team, you usually work as this trio, which is product design and 3D prototyping and art. Product designers are us, basically, and we are responsible for all those things I mentioned before, all the product thinking, strategy, where is this going, the whole vision, setting the story so that people understand what we're building and talking to users and translating that, but also creating all the Figma specs, user flows, all the journeys, and managing the cross-functional relationships. So basically, you're the bridge between the product manager, engineers, and how all that comes together, essentially. And that obviously includes all the spatial and environmental design when you're talking about VR. Prototypers, on the other hand, they add an extra layer of complexity. It's very similar to what our friends just mentioned now. Like, some people are more tech-oriented, and they can code. They can use engines like Unity, Unreal, and they can basically bring a few of those things to life. So they are often the people that help you prototype your concepts, and so that it become alive, alive. And then they can help you with UX research. They can also sometimes collaborate with engineers very closely, because some of them can really build the final implementation of your designs as well. And artists are the people that actually are very, very good at visual and 3D design. And they usually help with concepts. They also, sometimes the skills, they blur a little bit amongst those roles. But in general, they are very good at 3D design, know those engines. They can build a high level, what we call gray box, which is like a wireframe version of this. And they can help with the assets, sound effects, animations, performance. And all of this together makes a VR core VR design team at Meta. And talking about spatial design, as I said, we're going to touch again on a few things we heard just now. But to begin, the core concept of what this is that you can look at here, and those two tools, they basically allow you to do the same thing, right? However, in one side, we have a 2D version of it, where you have abstractions for things we call buttons, but they are essentially squares. They are not really a button. Someday, someone said, OK, you can click this, and it's a button. And we learned that, and this is what 2D software is essentially up to date, right? And we have a few rules for that to work, a few things we understand, a few heuristics and things that we know as designers. And when we come to spatial design, the main difference is that now you are in an actual 3D space, especially in VR, where you are fully immersed. You are there, right? You can really see things, interact with things, and although they are virtual, they are 3D. So you have this sense of reality. And that's what's the most impressive thing about VR, because even though you see 3D avatars, there is a sense of presence. I'm there. And at that point, we even have to take considerations around safety and stuff, because I forget about my world. If I have like no way to see what's around me, I can literally knock things around, and that's why we have many mechanisms to go around that. So that's basically the main difference between them. And I'm going to cover 5 topics here. And of course, there's many more. Some of them, as I said, overlap with what we just heard. And I hope you guys learn a little bit from this. And we can start with ergonomics, which is about, essentially, allowing people to be comfortably efficient in what they have to do in their jobs. That's the core definition of it. And the first thing is what we just heard, fields of view. So essentially, like we just heard now, you have an area you can look without having to move too much. Again, like least effort I have to do, I can see a bit of that. There's another region there that I can see with only my eyes, and I'm starting reducing that. And then if I'm talking about reading, there's a very small area here. So all of this you have to consider when you're now making a new world for someone, because you want them to not have to make a lot of efforts to achieve whatever they need to. When you go to a headset, this gets way, way smaller. So this is the typical headset field of view. This is Quest 2, which is very similar to the Quest 3S we just released. So it goes way smaller, because now we're covered here, right? So you can already see, like, I'm limiting a lot. There's a lot of saying about AR glasses in their field of view. It's exactly because of this, because with glasses, it's even worse, because if you just move your eyes to the side, you just lost your entire field of view, right? So this is the first thing you need to consider. and how much comfortable eye movement you are requiring from people. And this goes from side movement, up and down movement, and everything you demand for your application to work and for people to be successful using that. This is an example from workrooms where you can start applying those heuristics and this knowledge to make your decisions, right? How much do I require people to move around to see that screen if I want that to happen? If I want this guy to talk to her, it's much more effort than just having him look straight, right? And is there anything I'm requiring them to do that they have to completely turn around? So you have to start asking those questions based on this knowledge, and that's why this is important. This is another example of that we saw a very similar one now from Vision Pro, where in this exploration from Quest Design System, they focused like the most important information in this 40-degree area there, so that with just your eyes, without even moving anything, you already see what matters for that point, right? And the next thing up to ergonomics is the depth, how far things are from me. Too far, I cannot see really well. Too close, not very well as well. So there's an optimal region there that I need to put things. And a normal eye typical focus distance is about 1 meter away. And that's generally where you should start thinking about putting your elements. And this will determine the size of things. So if you are a UI designer, for example, where you typically think about pixels, but here, pixels is just the first layer, and now I have to think about where will that be? You calculate this angular size, and then you get like to optimal centimeter size, because again, remember, it's a physical object in the 3D space, and now you have to think not only about the density, pixels, and stuff like that, but how big is this? Is this covering everything? Is this too small? Can I really see what is in there? And the depth also can make your interface vary depending on where it is. So here's another example from workrooms where at some point we had a wall where you could go for like whiteboarding, and you had your desk tools as well. And depending on where you are at that point, your interface could be bigger or smaller, you know. So this is a different consideration from when you are doing typical 2D design on flat screens. A next point to this is curvature, because if you stretch both your hands, you can even do it now, and if you move your one hand, keeping the same distance, you'll see this one is now much further than this from your eyes, right? So if your interfaces start getting too wide, you can start curving them. And then you see, OK, this is as far as this. So basically, I render the same amount of pixels here and here. So that's another thing that, again, it all together adds to the comfort side of things. And lastly, reach, which we briefly heard about as well, which is how much am I requiring people to move around? In workrooms, we have a desk and we have a computer. So how far your hands reach and how far they reach even without stretching is what we call those two areas here. So that's your maximum reach zone and your comfort zone. So essentially, you would require tasks they have to do a lot within comfort. While a few things that they don't have like to do as much, you can require a bit more effort, and some things you can't require at all because they could be too far. And talking all about this, next topic would be movement. So we are now in a 3D world, right? Different from what we saw where you might be sitting, like workrooms experiences or some of the Vision Pro experiences as well. When you are in the VR world, you can move. Basically, you can walk around. You can have entire worlds like video game experiences and stuff like that. So we have to consider a few things. The first is definitely motion sickness, which I guess if you ever use the VR equipment, you probably felt it a little bit. And this comes because your vestibular system perceives one thing, your eyes are seeing another thing, and then it gets all confused and thinks you're poisoned, and then you want to throw up, essentially, right? There's a few good practices to consider when you're thinking about this. Of course, you can go deep into any of those, but I'm just here to say that you have to think about that if you want to work like in immersive experiences, because the more you require people the more you can confuse and trick their brain, and these experiences, as I mentioned before, they will do that, the more you need to be concerned about like how much you can predict of things that can cause this type of discomfort. And then you work around that too. And when we think of movement, we have two types. The first is what we call stationary experiences. And basically, Stationary means you're not moving, right? And they can be seated, they can be standing, like those games, like Beat Saber type of games. But in essence, you don't move around the space as much. You have preset positions that you can locomote to, depending on the experience, but you don't have to physically do anything. Ambulatory, on the other hand, you or your character, they can move. So Horizon experiences, for example, in Horizon Worlds, or many other game experiences, the user can walk around, they can slide through the world and do many crazy things, right? And that's where motion sickness gets really dangerous. When we talk about movement, there's different types of locomotion. The first one is what we call hotspot. This is for stationary. So basically, you have those hotspots, those preset spaces where people can move to. And here's an example from workrooms where you toggle this mode where you say, I'm moving now. And then you have to have clear affordances and places, signifiers for users to understand. That's where I can move to. And then it has to be simple as well, depending on the operating system. Vision Pro has their specific interactions, Quest has theirs. So users can quickly understand, okay, this is the gesture I use, or this is the interaction I use, this is the button I press, and all of that. The other type, which is not so common, is what we call room scale locomotion. Essentially, you render a part of the room. And this is, we used to have this in workrooms when we had this wall whiteboard. So essentially, user could walk to that spot, but then because of safety, we used to film the area they were around. And as they moved, that you could review more and more of that space, right? The con here is that it requires one, that user stands up, which we might not want them to do many times. And second, they need to have a physical space to do this. So you don't see this as much, but just so you know, it exists, and you'll see this every now and then. Continuous locomotion is the typical video game interaction where you slide through the roads, and this is most common, and like I said, the most kind of prone to motion sickness as well. The methods to do this can vary, because it might have 2 controllers to do that. I've never seen someone being really successful doing this with only hand interactions, so it requires a bit more of that. And there's a few techniques, like you see here, this vignette, that you see many experiences using to reduce a bit of that peripheral motion that causes a bit of sickness there. And another type of free locomotion like this is what we call teleportation, which is still of continuous locomotion, but instead of moving through and sliding through, you point and then you essentially are there. You jump to that spot. It's a bit less immersive, but it still allows you to move throughout all spaces. Next topic is perspectives, which is how does a user's point of view affect how they interact with the space they are. So here, first, we have sightlines. This is an example of what I mentioned, a gray box. This is from one of the Horizon World spaces called Horizon Plaza. Essentially here, we wanted to understand when the user arrives, what do they see first? Do we want to encourage that they explore the space? Do we want to show that they can, for example, go through stairs or not? Do we want to clearly state what they can interact with? So here, for example, it's very as I mentioned, like a wireframe, but this is a portal that they can travel to other spaces. So this is important because it should be clear to users when they arrive, especially in those immersive spaces, that they know what they need to do or what they can do. And again, being in an immersive app also kind of implies it should be fun. So there's a lot of the game design thinking behind this, which again, next time you play video games, pay attention to this. You are encouraged to explore, right? So the first thing you see when you play, try to pay attention. Is it clear for me that I can go there, that I can do this and move here, move there? The learning curve is really quick, usually with video games. And we try to bring this into this interface design principles as well. Next to this is still on sightlines, is especially in those social spaces, because that's another very powerful thing of VR, where you can connect multiple people together at the same time. How much my point of view is maybe harmed by the tools I give them, right? Here's an example for workrooms again. We have a computer there, and typically, if you have a computer, especially in VR, now I have all this power and I can like do whatever I want in my world. I want this huge screen there. Maybe I want like 5 screens with me. But one of our priorities is we want people to be social. So how do we balance that? So how do we cater for people that might be taller, might be, I don't know, behind versus not? So you start making trade-offs based on like those principles. And here, for instance, we decided that after testing and all those things, that seeing the head of the person while they speak should be enough, right? Maybe seeing their hands as well, like, is enough. And we ended up giving user the agency to choose the size of their screen. So we have 2 sizes. And then like for some time, if it doesn't matter if we're covering like the other person because of whatever they're doing, they can have a bigger screen. But if they want to prioritize speaking, they have it small. So we ended up outsourcing this to the user itself. Another point is what we call perspective. So divergent viewpoints, meaning not everyone will see the same thing as you. A way to work this, we usually do those type of diagrams. Again, we have very real physical sizes for those things, right? A desk is actually the size of a real desk when you do this. So you can start bringing even knowledge from other places like architecture and interior design and things like this. Artists usually help with this. And then you start determining those points, right? So here, for instance, this layout, we call conversation layout, is optimized for conversation. We have a screen here which shares content, but the actual principle of this room is conversation, meaning that this person has a much better view of that than this person because they have, again, remember the neck effort and stuff, they have to turn around. So because of this, we have multiple layouts. And here's an example of a different one, which is a presentation layout. And that brings another topic, which is the shared frames of reference. Essentially, when you are in the same room like we are here, you guys know where I'm pointing at, right? So if I point at that guy here, might be a bit harder for some people, but you guys know I'm pointing to the third avatar there. This in VR is very important to maintain this feeling. So here, for example, the priority was that everybody should know what everybody was looking. But at the same time, you have to consider things like privacy, for example. So we know here that every one of them has a computer. But we don't really need to go as far as showing what they're really looking at for this specific point because of privacy or whatever. But we should balance and know like what is enough in this sense, right? Another interesting point in this is that we can create illusions. Like the people in the front have one size of screen, and it increases slightly depending on where you sit and how far you are. So the further you are, the bigger the screen is up there. If I'm pointing here or here, it doesn't really matter. You don't really notice the difference. So there can be some divergence. So you optimize for the things that really matter to you. But again, you always should consider, like when you're talking of experiences that have multiple people interacting with them, how much you share reference between them. Another interesting topic that I like a lot is shared interfaces. We think of shared interfaces for 2D, like, I don't know, Figma or apps that you can use at the same time with other people. But we never think that it's one client per time, meaning one person in one computer, another person in another computer. There's never 2 people in the same computer doing the same thing. And this happens here, right? So we can have a single interface with multiple people interacting with it. And then we have to start asking questions like, who sees the state of that button when she clicks? It's selected and it opens this. Do both of them see it? Is it a shared frame of reference? So meaning, do they see it in the same place at the same time? Can they overtake the action from the other person? So all those questions start coming up. And again, it's a mix of being immersed with being social in the same experience at the same time. And it takes me to UI, which I'm not going to go like as deep as my father went with design systems, of course. But essentially, there's 2 types of UI that we will see in these experiences. And the first is what we call diegetic and skeuomorphic. And probably most of you know what skeuomorphic is, which is an UI that replicates the real world. You guys probably remember the iPhone calculator that looks like an actual calculator early in the day, right? And diegetic comes from cinema, where the sounds that are part of the scene, that's what we call diegetic. So if a door slams and you hear that sound, right? That's called diegetic. So essentially, it means that the UI are actual real objects. So here you see them grabbing a fishing pole in this horizon world there. And that's their UI. They don't have to click a button. There's no abstraction. It's the actual thing. It could have been a paintbrush where you can like get your paint and use it to do it. So VR allows you to have this liberty and creation. And it's up to you how far you allow people to use them. And the second, of course, is 2D UI, which most of the new experiences and new technologies like Vision Pro, for example, end up falling into, which is the traditional 2D UIs you have. And we have like 40 years of evolution of this and learning, and people are very familiar. So although some people might claim sometimes that they are not as creative as like me getting a fishing pole or a paintbrush, they're still very powerful and serve a very important purpose on interactions. And for tasks that need to scale, or for things that are too repetitive or need like proper attention, for text, which is essentially a 2D construct, they are most appropriate. And my final topic on this is social dynamics. So as I mentioned, VR allows you to have a space with people around you. And there's many things I could say about avatars and things like this, which could take hours here. And I'll mention 3 topics which are very interesting in my opinion. And the first is spatial sound. This evolved again through the years, and it brings so much realism to VR. And it essentially means that you, because of technology, you know with the direction of sounds where they are coming from, if they're coming from the back, if you are close to objects or if you're further. And it basically creates all this immersion. And it's interesting as well from an accessibility perspective. Once we had a session with a company, they are specialized in blind people using VR. You're using VR. Some of them are not completely blind, but still sound was their thing. Like the devices, some were AR devices as well, they allowed them to navigate through the space, read content, or to know where they were looking at without them having like ways to see. And for those that could see a bit more, the sound was essential for them to kind of have a better mental vision of what they were interacting with. Proxemics is an interesting one, which is essentially the study of personal space. So there's 2 angles here. One is, how much space do I need for things to be around me so I don't kind of start touching other virtual people? You know, that's the first thing. But the second thing is safety. There's a lot to think about on my personal space and how much do I need so that I don't feel it's being invaded. So I make those experiences comfortable so I don't make it feels like, I don't know, I can have my personal bubble where I feel like I have control over that particular spot. So this is really interesting. There's many tools that we need to think about this, not only the space, but how to essentially block sometimes. I saw experiences, I think even in Horizon Worlds, there was this at some point where you could literally go to your invisible space. At that point, it was overwhelming. Too many people, I can go to basically my safe spot where there's no one can see me, I don't see anyone. Very interesting topic to think about as well for this. And communication, of course, which is when you use all of those points, you are saying that's essentially what you're doing, right? You are facilitating so people can communicate. And a few things can be literal tools. For example, in workrooms, we have a way to raise your hands because it's a meeting tool. So essentially, you have to do take turning. But we have things like social gestures as well. This is a prototype, one of the examples I mentioned to you guys, like that's done a bit scrappily, so we test things. And we allow people to do high fives, fist bumps, and it adds to this realism and the sense of you being in a place, although you have like just virtual content around you. And after 2 talks of spatial design, I know it's a lot. So I know this is like a kind of a deep, heavy content. So if you go like really, really into it, but it's really interesting. So if you are passionate about creating experiences that are immersive, if you like game design, I really urge you to take a look at those principles when you can. Again, feel free to connect. Feel free to reach out today as well if you want to talk about any of this. And I would like to finish with one quote that says, virtual reality is a self-created form of chosen reality. Therefore, it exists. So what do you think? Are virtual realities real or not? So, thank you very much.